All right, let's finish up these last couple examples here. So this one's kind of annoying. This is one of those, it's one of these Pythagorean identities, but it's one we didn't even cover last year, to be honest. To me, it's kind of like the most useless one. Anyway, whatever. So, you AP test takers know it. The rest of you don't have to worry about it. And honestly, AP test takers, I can't believe it's probably going to be like one or two, maybe probably one multiple choice question. So, turns out that we have these things called half angle formulas. Those who take some college algebra, college trig, you will probably see this. You might see this again. Like I said, I don't like it as much as the other ones. So, cosine of my angle over 2 is equal to plus or minus 1 plus cosine of x over 2, all getting square rooted. So keep in mind this was cosine squared of the, so when I take this and I square that, what's going to happen to my plus or minus and my root? They gone. So now I can then go with, what color? Let's go with the purple. Can now do a rewrite of the integral. I've got my constant again, so that's not going to worry me. But now once I square this, because it's cosine squared, when I square this, the root's gone and the plus or minus is gone, and I get 1 plus cosine. Now remember, this is when it's x, we're talking about m here, so make sure your variables fit with your variable of integration. Let's clean up early and often. I'm going to do two things. I'm going to take this 3, I'm going to distribute it to the top, because this is 3 over 1. And I'm also going to split this fraction up into two pieces. So I now have the integral of, so this is 1/2 times 3, which would be 3/2, plus this is cosine m over 2 times 3, which would be 3 cosine m over 2 dm. And now this is something that I can integrate. So the integral of 3/2 is 3/2 m, not x, plus, try to pause this and see if you can figure that integral out on your own. All right, so the 3/2 is no big deal. That's just a constant. Integral of cosine, I always do my integrals. I got to make this little chart. I don't have them memorized. So I want to integrate cosine. That means I'm starting on this side and going this way. So if I called this, actually I'm going to add that. I like that. If I called this f, this would be the integral of f. So now this time, what I'm trying to integrate, my function is cosine. So when I integrate, I'll get sine. Life is good, no negatives to worry about. So sine of m. Box it in, put it up on your fridge. No. What did you forget? Hopefully you didn't. That's stupid plus c. All right, I think you should be able to attack this one on your own, so I'll give you a second. Well, you take as much as you need. Hit the pause and go. All right, let's see how you did. We always want to, there is a product rule version of integration. We don't get to it, but well, I think there is. But why would we try to do that when we can just clean this thing up? So my math voice says I can square this, and then I can distribute this in there. I can't distribute first. The squared is tougher. So that's going to be z cubed times the quantity of, you can write it twice or just do it in your head. 3 times 3 is 9. That's a minus 6. That's another minus 6, so that's minus 12 z's. And then negative 2 times negative 2 is positive 4 z squared. So now I've expanded the quantity. Now I'm going to distribute the z cubed, so I get 9 z cubed minus 12z to the 4th plus 4z to the 5th. This is what I'm trying to integrate. My variable of integration is z, so don't forget your dz. And then this is nice because it's a nice little polynomial, so we can do the integral shortcut, add 1, divide. So this would be z to the 4th. 9 divided by 3 is 3. Oh, my bad. No. Yeah. Divide by the new exponent. Divide by 4 minus 12z to the 5th, divide by the 5, plus 6. Ooh, so this is going to be 4 over 6, so that's going to end up being 2/3 plus C. All right. Simplify early and often. I'll give you a chance. Think about how you can simplify this. There's actually 2 nice ways. All right, let's see how you did. So one way is to take the numerator and try to factor it. So my math voice says, can I factor this? And if anything cancels, life is good. So I'm going to try to factor x and x. 14, yeah, that works. 7 and 2, right? I need a -7 and a +2. So those 7s, x minus 7s are gone. And I'm left with the integral of x plus 2. Now, to be honest, that's not going to happen very often. You're more likely going to have to do a move called synthetic division. I don't know if you remembered that move, but it's been a while. So I'm going to pause you, or I'm going to recommend you pause and try to synthetically divide this. All right, let's see how you did. Remember, this is the divisor, so this is the thing that goes in the little house, but you've got to rewrite it as a 0. So that becomes a +7. And then I just list my coefficients, 1, -5, -14. The 1 automatically drops. That's 1. 7 times 1 is 7. -5 and 7 is 2. 7 and 2 is 14. Add those up and we get our 0. Now remember, this was an x squared. We divided it by x, so this is going to drop by 1 level. So that's going to become 1x plus 2, which is the same thing that we found here. But to be honest, they don't usually factor when it comes to the actual AP test. So now we want to integrate this bad boy. The integral of x plus 2. Super easy to integrate. I'll give you a second. All right, so I would add 1 and divide, so that's x squared divided by 2. I would add 1 and divide, and then don't forget your constant at the end. All right, so that's the end of notes. Dig into the homework. I've got the answer keys posted. You can check there, or as always, you can go to El Corpi's good stuff and look at his answer keys if you like his better. All right.